Good morning. So today's topic is going to be HDLC. HDLC is a high level data link control. So why we are using HDLC? In data link layer, so this unit is going to be full of data link layer. So in data link layer to pursue communication, we use HDLC. It is going to be for both point to point and multi-point links. What does it mean? Means it is point to point means it is going to be a direct communication between two systems or servers. But multi-point is from one to many. It is used in both the cases, and here we use ARQ mechanism. So ARQ mechanism is now, as we have discussed earlier, it is for error detection, and we use that mechanism also here. And we have two modes in this. One is going to be normal mode and the other one is asynchronous balance mode. So first let's see what this normal response mode is. So in normal response mode, we'll have a primary and a secondary computer. So primary is the one which is going to send the data and the secondary is the one which gets the data. So here we say this normal response mode as unbalanced because so we are going to send a communication, that is a primary command, a primary node is going to send a command and response will be from the secondary node. So here only the primary can send any commands, or primary only can initiate the uh, primary only can initiate the data to be sent. Secondary node can only just respond to it. So we are saying it as unbalanced. In this we can have point to pointers, we'll have one primary and one secondary, but multi pointers we'll have one primary node and more than one secondary nodes. So this is going to be normal response mode. So normal response mode is going to be an unbalanced mode because only communication can happen from primary. Secondary can only respond to it. Next is going to be asynchronous balanced mode. So this we are saying it as balanced. Why we say it as balanced is both the primary and the secondary can send the command and the response. Here both the stations will act as a primary and secondary node. So this is called as asynchronous balance mode. See here, this is going to be your primary, this is going to be a secondary, or sometimes this can act as your primary, secondary, and this can act as your primary. So both has the capability to act as your primary and your secondary node. So we are telling it as asynchronous balanced mode. So frame. One of the important factors in a data link layer is going to be frames. Frames is the form which we send the data in the data link layer. Here in this we have three types of frames. One is going to be information frame which we call it as I frames, and the other one is supervisory frames which we call it as S frame, and the third one is unnumbered frame which we call it as U frames. So these are the three different types of frames which we use in HDLC. So in this first iframe is used to carry the user data which the user sends. So it includes both flow and error control. But S frame does not have any data in this. It only have the control information. That is, it only has flow and error control mechanisms. U frame is for system management. That is what the link within the system. The user will not play any role in this U frames. Only the system which sends the frames are called as U frames. So in frames, we have different types of fields which we have discussed while studying the OSI layer. So in this, we have different fields. So first is going to be flag. Flag will be in both the starting and in the ending of your frame. In any type of frame, we'll have flag at your starting and the ending. So in the starting and the ending, it is mainly used to differentiate the differentiate with other frames. So if we have flag at the starting and the ending, it means that a new frame is going to be sent. So that is the use of the flag. Then it is going to be address field. So address field contains the address of the secondary stations which the data is going to be sent. So if primary station is the one which created the frame, it contains a two address. So that is called as secondary station address. So for example, if secondary station want to send a response and it creates a response and it creates a frame. So in that frame we will be having a from address. So this is the role of address here. Then it is going to be control field. Control field is going to be for flow and error control. We know what is flow and error control, which we have seen as a different topic in previous classes. Next is going to be information field. So information field is the one where the user information or the management information, whatever information that need to be sent will be in the information field. And FCS is called frame check sequence, which is used for HDLC error detection. So these are the different fields in the frame. So next is control field for iframes. So what is control field? Control field is the one which is going to have your flow and error control. So in a control field, if the bit starts with 0, if the first bit is 0, then it is going to be for iframe. Okay, so this 0 indicates that this control bit is going to be for iframe. So then the next three bits are called as sequence number. Sequence number is the frame number, which is going to be from 0 to 7, and the last three bits are called as response number. So response number is the one which comes from the secondary node. So that number is called as response number. So here we use the term piggy banking. So piggy banking is something that, for example, I am the user, I am the sender. I am going to send a message to you, and you are going to be a receiver. You have got the message. You have to acknowledge me that you have got the message. But in addition to that, you have to send some other message to me also. So you'll be waiting for that, and with the message you are sending to me, you'll send the response message. So that is called as piggy banking. So piggy banking is something that I am sending you a message and you have to acknowledge me for that. With the acknowledgement, you also send the data which you want to send. So the acknowledgement process will take some time. So this is called as piggy banking. So at the center we have a single bit called P by F. So this is for dual purpose. So if it is as P means pool, F means final. So if pool means, so primary station is sending a data from the data to the secondary station. If it is final means the secondary station is sending a data to the primary station. So in that case, we will be saying it as P by F. So P means pool and F means final. So next we are going to see control field for S frames. So the first two bit, if it is 1 and 0, then we will be saying it as for the control field is going to be for S frames. So if it is 1 and 0, the first two bit is 1 and 0, then we will be going to say it for S frames. So the last three fields, as we know, it is going to be your response number. That is your acknowledgement number which the secondary data gives us. So and this 2 bit is called as code, which is used to define the type of S frame. So what type of S frame it is going to be. So in that we have four things. One is receive ready, receive not ready, reject and selective reject. These are the four different types of yes frames. So if that field is, if it is 0 0, then it acknowledgement that the recipient is ready to accept your data. The frame which you have sent is receive. So it is receive ready. If it is 1 and 0, if this field is 1 and 0, then it is going to be ready, receive not ready. Receive not ready means the recipient is not ready to accept your frames. So if it is 0 and 1, then it is reject. It will give a negative acknowledgement number. So negative acknowledgement number we have already seen in the protocols. So it is going to be negative acknowledgement number. So we will be using it in go back NARQ. So if the subfield is 1 and 1, then it is going to be selective reject. It does not reject all the things. It just selectively rejects something, and we will be using it selective repeat ARQ. So next is going to be control field for U frames. So control field for U frames. If the field starts with 1 and double 1, that is 1 and 1, then it is going to be your U frame. So we'll identify that this control bit is going to be for your U frame. So it is used to exchange session management and control information between the connected devices. So this we mainly use for system management, and we does not use any user data over here. In this we have two sections. One is 2-bit prefix and a 3-bit suffix PF code. So here we see we have 2 bits, and in this we have 3 bits. So this only we say it as 2-bit prefix PF bit before the PF bit and 3-bit suffix after the PF bit. Then our next topic is going to be point-to-point protocol. So it is a common protocol that is used for point-to-point access. What do you think of a point-to-point protocol is? So where will we use point-to-point protocol? Yes, as I said earlier, for example, in your home you have a modem. So that is going to be your point-to-point communication. Your system is connected to the internet server in your home, which we will say it as modem. So that is a point-to-point protocol. So this is going to be between your system and your modem. So it is the point-to-point protocol, and we use point-to-point protocol there. So that is the point-to-point access. So now we'll discuss the services provided by the point-to-point protocol. So first it defines the format in which the data is going to be exchanged between the devices. So that is going to be the first point. That is, it defines the format of the frame. Next is it just negotiate with the two devices. If there are going to be two devices, it talks with them and then finalize the link that in which the data is going to be exchanged, how the data is going to be exchanged. So that is going to be your second service provided. Next is, in data link frame we are going to get the data from the network layer. So network layer, it will be in the form of brackets packets. So this defines how the packet is encapsulated into the data link frame. Next, authentication. So we know what is authentication. Authentication is only the users who are able to access, who the trusted users only will be able to access the protocol. So authentication is provided in this protocol. Only trusted users can work in this. And it also provides connection for multiple links. So then it is going to be provides network address configuration. So network address is something that is related to internet. So the internet address, it will also provide the internet address in which it is going to be connected. So these are the services provided by point-to-point protocol. So now we'll see the services missing. What are the services missing? First is there is going to be no flow control. First there is going to be no flow control. Next is only a simple mechanism for error control is used. So it does not, as HDLC, it does not focuses on flow and error control. So there is no proper addressing mechanisms. So next is going to be framing. So in point-to-point protocol, we'll see how the framing is going to be. So we have different fields in the framing. As we know, flag. Flag will be in the starting and at the ending of a frame. Why we use flag? To differentiate between with the other frames. So that is what the main purpose of the flag. Then it is going to be address. The address is the one gives the address of the frames which we are going to send the frame. So address of the device in which we are going to send the frame. So that is what we use, address. Then the next one is control. So control value is going to be 0000000 dot double one, which is imitating the unnumbered frames in HDLC. So it is going to be a constant value. And then is protocol. So in the protocol field defines that the data which we are going to send is whether the user data or some other information. So that is the definition of the protocol here. So protocol defines that is going to be a data which is sent by the user or some other data. Then it is payload field. So this field, so protocol field just defines that it is going to be user data or some other data. So payload field is the one which is going to carry the information. So that is the difference between protocol and the payload field. And we have FCS that is used for error reduction in this frame. So we'll see the transition phases in this. So what do you think of transition phases? So transition phases, we see how the protocol works. So first it will be in the dead node, dead state. So there will not be any active carrier. So if someone is going to initiate the communication, when a node starts for the communication, it will automatically move to the establishment mode. So when the dead state is moved to an establishment mode is when the when any of the node need to start the communication. So after the communication, we have two options. One is the system need to authenticate whether the data is given from an authenticated user or not. Otherwise, simply the exchange of data. It will move to the open state. So here we have two states. One is going to be either authentication, system needs authentication, or it moves to the open state. So if in the authentication state, if it is not authenticated, the authentication is failed, the user is not trusted, then it will move to the termination field, or it will move to the open field, and then in the open field the data transfer happens and the communication happens, and after the communication over it moves to the terminate node. So first the data which we are going to send, so once the node need to start the communication from the dead state, it will move to the establishment state. In the establishment state we have two phases. First is authentication. If the authentication failed, it is terminated, else it moves to the open state, and from the open state, after the communication over, it moves to the terminated state. Else it can directly skip the authentication and moves to the open state. So this is the transmission phase. So in this we have three set of protocols. One is going to be link control protocol, two authentication protocol, or network control protocols. So link control protocol is only one. Authentication protocol is two. So we'll have two authentication protocols in that. And then network control protocols, we'll have several network control protocols which can be combined. So this is the three set of protocols. So first is link control protocol. Link control protocol which we use mainly for establishing, maintaining and configuring links. So in the link control protocols we have a code. So for the codes we have different types of, in the code we mention the different types of packets. So the first four is going to be link configuration packet. So if you need to establish the packet, we use either the for first four nodes. Then we have second category is second 5 and 6. So in this it is used for terminating the links, and the last three is used for monitoring and debugging the data. So these are the different types of codes in the link control protocol. So next is going to be authentication protocol. So in the authentication protocol is mainly used for validating the identity of the user. So authentication protocol is mainly for validating the identity of the user. So in this PPP we have created two protocols for authentication. So one is password authentication protocol and the other one is challenge handshake protocol. So in the password authentication protocol, it is going to be for normal username and password type. So if the password is wrong, then the authenticated is, if the password is wrong, then the authentication is not correct. Then next is challenge handshake protocol. Once we give the username, automatically the password will be generated from the other end and then it will give it to us. So that is going to be challenge handshake protocol. So in this we have, so that is what we have discussed. So password authentication is you'll have the username and the password. So in challenge handshaking protocol, so the password will be kept secret and it is never sent in the online. So next is network control protocols. So in the network control protocols, we have different types of protocols, IPCP, OSI, and many kinds of protocols are there in this. So in this we only discuss about IPCP protocol. So IPCP protocol is a Internet Protocol Control Protocol. So it is mainly used to carry the IP packets in the internet. So in this code, we have configure request, configure acknowledgement, n acknowledgement, that is not acknowledgement, negative acknowledgement, reject, terminate request, terminate acknowledgement, code reject. So these are the codes that can be given here. So with the code, we will be able to identify what type of IPCP packet is going to be transmitted. So this is all about your BPP protocol. Thank you.